I'm very glad to be here. It's I'm here because the G20 is here. And we're going to talk about things around innovation and the knowledge economy and how, in the face of financial downturns, how do you get the economies moving? And we believe very strongly that telecommunications and mobile broadband, these are critical elements. And of course, it's very appropriate that this is happening in Korea because from my standpoint, Korea is really the cradle of technology that forms the basis of 3G. We developed it at Qualcomm, but it really was made mature, and working with partners here in Korea really was a thing that sort of made the company. And so Korea has a very special place for us. We do try and give back, and I think some of you here are alumni of our IT Students Tour, is that right? Good to see you guys again. And so we always bring the students in every year and give them a chance to see how Qualcomm works, and maybe expose them a little bit to San Diego too, because it's not such a bad place to be. But what I wanted to talk to you today about was sort of the story of Qualcomm, and framed in a certain way to kind of talk to you about how innovation happens at the company, because it's a company that's really based off of ideas and getting those ideas into the market. And so the question is, sort of how is that done, and how do we run the company in such a way that happens? So I'll give you a sense of that, and kind of see where we go from there, and kind of questions that you have about it. Maybe to start off, I would say the first thing is that the company's been around 25 years, and we just celebrated our 25th anniversary. And it was a company that came together out of 7 original people who had come from a previous company, and it was a group of people who came together actually without a particular product idea. They had a lot of experience, and they built the company into what it is today, the leader in wireless chipsets, and certainly a technology leader, a very large company in terms of the size of the business that we've been able to create at the company. And maybe I'll spend a little bit of time just kind of tell you some of the way the company's structured, and then talk a little bit about this issue of vision and innovation. So essentially the way Qualcomm works, as I said, it's really focused on this notion of creating ideas. And those ideas are brought to market not directly by us, but actually through partners. And so when we come up with an idea, we embed that idea into the chip that goes inside your cell phone. We sell that chip to a manufacturing partner. We license the technology to our partners. Those partners then sell their products to a wireless operator or through a distribution channel, and finally to the consumer. The money then flows back from that sale through the operator to Qualcomm, and it funds that cycle of research and development and innovation. And it's a very nice model for innovation, because at the company because we have this licensing business, we can get into a new product area very, very early, before it's even ready to take off to the public. And we create the technology, the intellectual property, the patents, and so forth. And then we start working with our partners to bring that technology to market. But in the case of things like wireless internet, it took a fairly long period of time for that to take off. And in the meantime, we were creating still more intellectual property, more innovations. And when it takes off, as it has now, we stand to benefit from it. So the business model allows us to invest very, very early into a new product area or a new technology area, and then still generate money. Whereas many other companies, when they get into a new product area early and the product doesn't come to market for a little while, they miss out. They lose out on it. And so I think that model has served us extremely well. The other thing that we've really focused on is sort of our core values. When I took over as CEO in 2005, and the company was known for innovation and execution, that we would come up with new ideas. And when I say execution, I mean that we would bring those products to market, we would commit to schedules, we would commit to performance, and we would get those to market. And we were known for that. But as you see how this model works, it's really important that we work through partners. And we weren't as well known, I think, for partnering, even though it was fundamental to our business. And so I really focused the company on that. I got up at the first all-hands meeting when I took over as CEO, and I said, these are our core values: innovation, execution, and partnership. And the story of Qualcomm in Korea really is one of partnership. I started out, we had a handset business. We actually started out selling CDMA phones that were built in San Diego to LG to sell into the market. Quickly that turned around the other way. And we found out that in fact working through the partners was a really critical enabler for us. It allowed us to scale our efforts much, much more broadly than they might otherwise have been scaled. And so that allowed us to focus in on the areas that we knew best. How to drive the next radio technology, and now of course it's grown into, because the phone's so much bigger, we've grown into many, many more things that go into a phone than just the radios. But we could focus in on the enabling technology and drive that and work with our partners to get those technologies out into the market. And this cycle that you see just continues to drive that idea that it's through partnership, it's investments that come early, that funds ideas. The ideas are valuable because they create licensing revenue, but we also can take them to market through a chip business, so we can create products in conjunction with our partners and get that out into the market. And so that's critically important to us. Another thing that's obviously important when you're investing or when you're dependent on ideas is investing in creating those ideas. So if you look at the kind of numbers in terms of how much money we spend, we put a great deal of emphasis on investing into research and development. And so you see the numbers in terms of the percent of revenue. Over 20% of our revenue, over $2.5 billion was invested in our fiscal year, which just closed. And that investment is, I think, one which actually works in a very unique way because of this partnership structure. So when we license technology to people, many times if you're a manufacturer and you're looking down all of your costs, the cost of the parts and various costs, and you get to this line and you see license fees, that causes people to push back. They say, well, I'm paying this money for this license fee, why am I paying that? Well, this is the reason why they pay for the license fees. That $2.5 billion that got spent on research and development, unlike many companies who spend a large amount of R&D dollars, but they're spending it for their own products, we spend that R&D money and we put it into products that our partners make. And so if you look at how the model works, the investment in R&D is actually funded across the industry, broadly across an industry, by this licensing program. And so we look at it and we say we're actually aggregating research and development for companies. And what that does is it allows companies who might not otherwise have gotten into these markets to get in and become very successful. And if you look back in the early days of our partnership in Korea, the companies that became very successful started out really as consumer electronics companies, not as wireless telecommunications companies. Today, they're leaders in wireless telecommunications, but that came about because of a shared development process and because we were able to take licensing money, drive the wireless technology forward rapidly, give them an opportunity to differentiate their products, generate good margins on their products, which then funded their continuing development as well. So it's always, I'll keep coming back to this notion of cycles, that the money goes out into creating the ideas and into creating the products through the partners, and then cycles back to continue that model going forward. So then the issue is, how is it that innovation actually gets done at Qualcomm? And there's ways that are both formal methods for innovation at the company and informal methods at the company. So the formal methods are things like corporate research and development. So there is actually an organization of people whose job is not to bring out new products, but actually to bring out new innovations and new technology ideas. And within that organization, they prioritize certain projects. The projects come up through that organization, or they gather them in sometimes, and then they shepherd them through the innovation process, the development process. But that group of people knows that every day when they come to work, this is what they're working on. How do you innovate? How do you do the next thing? They're working on specific projects. That's it's a large group, but certainly nowhere near the size of the entire company. And one of the things that we've really focused on is trying to allow everybody in the company to be part of the innovation process. And so the other formal method that we have is called the Qualcomm Innovation Network. And what the Qualcomm Innovation Network is a website and an email list manager where employees from anywhere in the company can put their idea into the website, and there's structured questions around it, so they have to think through their idea. It's not just like, oh, I woke up this morning, I had this idea, and I wrote it on the website. It's sort of, what's the idea? How can Qualcomm be successful with it? What is it actually addressing? So on and so forth. And we put it into this process, and then people around the company can see those ideas, and they can comment on them, and they can rate them. And then there's a workflow process behind that where once those ideas are in the system, then at certain periods of time we have experts get together. And they look at the highly rated ideas, and they say, okay, well, this idea is good, let's keep doing this. This idea is not so good, let's put this one back on the shelf. And the output of that process then goes to what we call our Venture Fest. So every year we run a Venture Fest where we select a certain number of these ideas. We take the people who created the ideas, we put them together in teams, some engineers, some business people, might be anybody around the company who might be able to contribute to that concept. We create teams with them, and then we put them through a boot camp, meaning that they go through and they meet with business school professors, they meet with experts within the company, experts outside the company, they go to places to learn about innovation. We work with a number of companies that specialize in that, and they actually put together a business plan for this idea that they've had. And those business plans then get passed on to the senior team. So all of the executive vice presidents of the company and above, we sit in a room one day and listen as 10 of these groups come in and present. And you can imagine, people are a little nervous presenting to the top people in the company sometimes, but they do a really good job because they've been sort of through this whole process. There's people there who are passionate about the idea that they have because they put it in a long time ago in this website, and now it's sort of made it through this whole process. And it's exciting because a lot of the ideas that are actually big ideas in the company right now came from this Qualcomm Innovation Network. And so the way I look at it is, if you think about a funnel, the corporate R&D is a somewhat narrow funnel with a lot of output. The Qualcomm Innovation Network is a very wide funnel with maybe a smaller output, but the ideas that come out of that are very good. obviously, we also get innovative ideas through the business units. The most of the development that happens in a business unit, though, is really focused on their products. How do they evolve the product to the next thing? Maybe they see some new disruptive technology that they can fold in the product, but it's very often that it's focused in and narrowed by the fact that those business units have a set of products that they're working on, that they're trying to bring out. And then we have this very informal method, which I think of it. Oops. How do I get that off? Escape? All right. Thank you. And so this kind of informal process, I think of, it's almost like a bubbling pot. And little ideas come up and they bubble up throughout the organization. And usually they come from one person who has an idea and they say, you know, I want to do something with this idea. And the way that we as managers see that idea is, if it's a good idea, a bunch of their friends start working on it. And pretty soon you got 5 or 6 or 10 people working on this idea, a lot of it in their spare time. And when you see those kinds of ideas where they sort of they accrete people to them, it's like a snowball, gets bigger and bigger. And then we manage it at that point. And we say, okay, that idea, that's a good idea, let's move ahead with it, or we don't like that idea so much, and therefore maybe, you know, why don't you stop working on that? Or maybe why don't you put it into the innovation networks, or put it into the more formal process and manage it that way so that it gets resources. And a number of the projects in the company happen that way. In fact, as I was a young engineer in the company, the majority of my projects started that way, and many things went through that way. Putting data services into the phone, putting internet protocols into the phone, started out as a little project. Putting GPS capabilities into the phone. Many things that you think of today as being a natural thing to be in the phone started out as these little projects where I had an idea, or somebody I worked with had an idea, we all got together and we built it, and then it became a more formal project. So I think it's very critical for innovation to occur in a company that you allow both these formal methods and these informal methods to be there, so that everybody feels like they have the opportunity. And we motivate people very much by talking about the opportunity that they have. And for example, in the last quarter, we shipped 111 million chipsets. So now think about what that actually means if you're somebody who wants to innovate. I have an idea, I get it into a chip at Qualcomm. In 3 months, 111 million people's lives are affected by that. That's a pretty amazing opportunity, and it's something that really motivates all of the people that work at the company, because they know that they actually can have a very global impact on the world by what they do. And so we really do focus on that. Now, I talked a little bit already about the business units, how they do their innovation, but the key thing is that they are, as I said, really fundamental to this process of innovation and this process of innovate, execute, and partner. And so the chipset business, it's grown into the world's largest semiconductor business. And it's an interesting business focused on innovation in the following way. We don't run our own factories in that business. So the engineers in that business design chips. They then send them somewhere else. For example, Samsung Semiconductor does chip manufacturing for us as one example. But those chips, they're ideas, right? They aren't things. They're ideas. The design of a chip it's something intangible. And the nice thing about that is that because we don't run the factory and somebody else runs the factory, we don't spend our time worrying about what manufacturing companies worry about. If you're a manufacturing company and you have a large capital investment in a factory, almost the number one thing you care about is filling your factory, making sure that that factory is running at its peak levels. Otherwise, you have to what's called absorb the costs of not running it at the peak levels. And those costs can be very large because the capital expense that goes into building a factory can be extremely large. So by being fabless, instead of focusing on the factory, We focus on the ideas and the products that go into that. It's very, very liberating. And I mentioned, as I said, that we ship over 100 million chips, so we have this tremendous platform out of that business. And the platforms are synergistic because without the ability to take the ideas to market through the chipsets, the licensing business would not have any value. Because if you have an idea that nobody uses, then nobody's going to pay you for it either. And without being able to bring that to market, then it has no value. So we use the businesses synergistically. And as I talked about partners, I think the next number is really quite interesting. So we used to be in the handset business, and we'd make 3 phone models a year. And that wasn't a very competitive thing to do. Working through partners through our chip business, last year we worked to launch over 700 different handset models. So the scale that we get out of this partnering model is far, far in excess of anything we could have done as a single company. And so learning that lesson that it's all about building a large ecosystem, that was critical to scaling the company to be the size that it is today. On the licensing side, I talked about the fact that we can invest early, but I didn't talk yet about the partnership aspect of that, which is we learned at the early days of the company, we watched some other technology developers. Sony, this is probably before all your guys' time, but Sony had a video tape system that they didn't license broadly, and it lost, even though it was technically superior. So we set out right away to license extremely broadly, and the result of that is the technologies that Qualcomm's developed have been probably the most broadly licensed technologies in the world. We're certainly one of the largest licensing companies in the world. And so we focus now on how do we continue that. And the interesting part of the licensing business is as we generate new technologies, we don't charge new fees. So when you work with us, you get access to all the technologies that we create. And so a new technology doesn't have the friction of us coming in and saying, oh, well, do you want that next thing? That'll be X dollars more. We don't do that. We say, when you license with us, we will continue to generate value, we'll continue to aggregate R&D and drive things forward so you as a partner can drive your business. And now, all of these businesses are built on something that I find really exciting, which is, without hype, this is fact. Wireless technology, it's the largest platform that humanity has created. There's over 5 billion subscriptions to wireless around the world. So think about that. Think about the scale and the scope that you get through working on a platform like that. And now the technologies that Qualcomm has worked on, 3G, which provide not just voice and text, but mobile broadband, they're already over 1 billion users today. And looking forward, in 2014, must have pushed the wrong, oops, I'm going the wrong direction, sorry. In 2014, we see there are going to be 2.8 billion people using these mobile broadband technologies. So it's pretty significant. And you think about that in terms of a platform. That's, as I said, when we motivate our employees, we motivate our partners to work with us, it's those kinds of numbers that really get them excited. So when we started out, the phone didn't really need much computing capability from an application side. It needed a lot for the digital, for getting the digital communications part that I was talking about earlier. But it had, I don't know, tens of megahertz of computing power. And now today, you have chips in the phone that are over 1 gigahertz. And I know that maybe you guys didn't have to deal with the whole time when everybody was talking about how many gigahertz your processor ran in your computer. But we are talking about that now in the phone. And one of the things that we did as we focused in on this was we also cared a lot about the power consumption. So we made sure that when you used all this stuff, it really needed to not burn up, all the laptops that you guys have. I mean, essentially you're carrying around in that the life support, the battery, that's the life support for the screen and the processor and the hard drive that's in your laptop. That's why those things are so heavy. And the reason why your phone is so light is because the battery is very small and it's very, very highly optimized for power. But we're moving beyond this now, and there's all these computing platforms, tablets, and the ability to have multiple processors inside. This very interesting area. There's a lot of innovation that's going on there. People are very motivated by the idea that they're going to put more capabilities into these devices. And they're doing that in service of a lot of software as well. So lots and lots of innovations going in on the software side. The vendors who make these high-level operating systems, we support all of them. We're not trying to make a choice for our customers about which operating system that they should choose, and different ones have different benefits to them. And you can see things like Android. I mean, we're the biggest supplier of chips into Android. Windows Phone just launched from Microsoft. All the Windows Phone devices are built off of Qualcomm's chipsets, these incredible processors. And that came out of that vision that we have of the phone as that point of integration. And one more thing that we've done is, now that you think about the phone as a thing that you look at more than you hold up to your head, now we had to make the screen be much more efficient. So the screen now, when you're looking at it all the time, it's the thing that's using up a lot of the battery power. And maybe you want to use your phone outside, and you can't see the screen because it's in sunlight. So this technology is one that's like Kindle. You guys know e-reader with e-ink. Hopefully you've seen these things. It looks more like paper. This one looks a little bit more like a magazine. It's full color. It runs full video. So really exciting technology that we're doing there. And it's in service of this idea of how do we use the phone more, that we're going to look at it more. And one other thing that will be interesting about this is that this technology will allow the phone to be on all the time. So when you guys put your phone out on the table today, it's black. The screen's black. Even though the phone's on, it's up, it's talking to the network. It might be downloading your email or your social networking information or news, or it's doing stuff, even though it looks like it's off. With this technology, it'll be on. So a lot of opportunity for innovation around the idea that your phone will be on all the time, telling you information about things around you, or information that you're interested in, or the people around you, or the services that you might get, or the content that you might get. So I think that's going to be a fundamental change. Well, what's going to happen is the phone is actually going to act as an interface for you. It's going to be a sensor that tells you about things that are available in the world around you. And wireless is going to be embedded in all the things around you, and the phone will know whether that's there. And it'll allow you to control things in the world around you. It'll allow you to sense things in the world around you. And it will combine not just what's in the real world, but also the cyberspace world, the digital information that we all have. We all have clouds of digital information around us. This room has clouds of digital information. This presentation is digital information that is associated with the room that we're in. The cameras that are taking the pictures, the microphones, the speakers, the projectors, these are all services that are available in this room that your phone may be able to leverage. The lighting in the room is another example. So what's going to happen is that you're going to have wireless embedded in all things around you, and your phone is actually going to interact with those kinds of things. I'm going to give you some more concrete examples in a moment. But why is this possible? Because remember that story I told you about investing heavily at the low end to try and get these very inexpensive phones for the emerging markets. Well, that chip in the middle of that little circuit board, that's almost a phone by itself. And the circuit board, that little circuit board that's the size of a quarter, that is a phone. So now you take that little teeny device, this big of a device, and you embed it into things that are around you, projectors and thermostats and microphones and all sorts of display devices, all sorts of things like that. And now, all of a sudden, you have the ability to communicate and control all of these different things. And by the way, I don't think everything will have a radio that talks to the cellular network. There will be many different kinds of radios that actually get access, that your phone will have access to. So ideas where you put it into thermostats or electric meters so that you can control the load that's generated. You'll put it into an electric vehicle so your electric vehicle can tell you how far away you are from being able to charge it. Or when I go over to my friend's house for dinner and I plug my car in, I don't force them to fill my tank at the same time they're filling my stomach, because I can signal to the network that it's me who's buying it. Or if I want to buy energy that comes only from green sources, I can say that's how I want to get access to the energy, because these devices will all be networked. So really huge opportunity when we embed wireless into the smart grid. And now you can think about your phone working in conjunction with the building. So you walk into a room and the lights come on in the way that you want. You walk out of the room, they go off. In commercial buildings, this is it's actually starting to happen already, and it will happen even more as time goes on over the next 10 years. So huge opportunities for efficiency and energy savings by smart grids that are connected into the network and connected to your phone. Another area that I'm personally really excited about is healthcare. Healthcare is a huge issue. In the developed world, we have populations that are aging, and so the doctors are going to be retiring at the times when people need them the most. So we need to make our doctors more productive. We need to make people stay well longer. Really importantly, most of the money that gets spent in the medical system is spent on chronic disease, things like diabetes and hypertension. And those diseases are very, very able to be treated if you just manage the condition. So if you're diabetic, you keep track of your blood glucose levels, keep them in a certain range, then you don't have the problems, get the complications. Hypertension is a lot about fluid levels in your body. Just weighing yourself and taking a very, very inexpensive pill can keep you healthy. And in the United States, it's something like $1.4 trillion gets spent on chronic disease management. So if today, when you think about your phone, you think that you're in contact at all times with your friends and your family and your colleagues, not because you're talking to them, but because you have your phone and they have their phone, and you know you can talk to them if you want to. In the next 10 years, it'll be the same thing with your healthcare professional. And just like today, we don't think about the fact that our phone has a camera and it didn't always have a camera. In the next 10 years, you're not going to think about the fact that your phone is monitoring your health status and keeping track of it. It's just going to be a natural part of life. And so your health provider will be able to find out whether there's issues with you. And areas that we're working on there are new sensors that people are building that you can wear as opposed to being invasive and going inside your body. Now, we don't yet have a glucose sensor for diabetes that's non-invasive. There is one with a very small needle. You wear it here, it talks to a device, and continuously monitors your glucose. But there are things for cardiac arrhythmia. There's things for fluid levels. We actually have a company that's done one for calorie intake, so how much food you've eaten and how many calories you've taken in. I don't know whether you guys want that, but I'm looking forward to having that to keep track. Blood pressure, all sorts of ideas there on how you build a sensor that will hook into the wireless device and monitor. And this isn't just fantasy. There's already a system out there that Qualcomm's been working with a partner that's done cardiac arrhythmia monitoring. So you wear a sensor hooked up to a wireless PDA. In the past, if you were trying to find a problem that somebody had with their heart, you would put them in the hospital in an intensive care unit in a bed, and you'd monitor that person. Now, you give them this sensors that are all hooked up to the device, and it finds it. And when something happens, it calls, and the doctor can see what happened. And a clinical study showed that it's 3 times more effective to do the wireless device. And the reason is because you're up and walking around and exercising your heart as opposed to lying in a bed. And you can think about the cost difference of occupying an intensive care bed in a hospital versus somebody just wearing something on their body. And today that thing's all wired up. In the future, it's going to have radios that connect to it and so forth, that you'll be able to basically put it on like you put on a Band-Aid, a bandage, and you wear it for a little while and take that thing off. So this is a really exciting area. I think there's a lot of opportunity there as well. And then the other thing that's going to happen with this idea is that we're looking at how do you get more data down to the device. And so it's going to be all different kinds of radios. Those radios are not just going to be mounted on towers outside on buildings, but they're actually going to come inside the building as well. And all these things are going to work together to give you much, much more data, much richer access to content or services or anything that's around you, access to each other. We're doing a lot more work in terms of peer-to-peer technologies. So let me give you one quick example of one of the ideas along these lines. So when we put the GPS capability, the location capability into the phones, people said, when you walk by McDonald's, now McDonald's will beam you a coupon to tell you to come in and eat some food. And I always said that was crazy, because who wants McDonald's knowing where they are at all times so they can tell that when you walk by they can beam you a coupon? Doesn't make sense, right? What will happen in the future with some of these technologies that McDonald's will have, or somebody, I mean not necessarily saying McDonald's, but the restaurant will have something which is broadcasting information, and your phone will walk through and it will pick up that information. It's always going to be listening for what's around you. And when it hears that McDonald's is offering you a coupon, and if you like McDonald's, then your phone will alert you and allow you to interact with McDonald's. If you don't like McDonald's, you just walk on by. McDonald's has no idea that you listened to it. They don't know that anything happened. But you can imagine that now for coupons. You can imagine it for content. You go into your class and your professor has new course material for you and your phone just picks it up. You can imagine it in your house where your devices are recording stuff off of TV and it wants to transfer down to your device, or a new song came out that you want to have access to. Lots of opportunities for this kind of technology. So we're really excited about those kinds of aspects as well. And then this one I think is a very cool thing. And essentially what it is, it's the ability to take objects in the digital world and merge them into the real world. So today, there are these kinds of things that use the location ability of the phone and sensors in the phone so it can figure out how the phone is pointing to overlay images onto the world. Well, this image there is virtual. It's actually done in cyberspace. But you point your phone at the table, your friend points their phone at the table, the two phones are talking to each other, they see the image of the game, and they generate the image of whatever it is the other person is doing. So you play a game that's not actually there. And now you think about things like 3D TV, how people are so excited about 3D TV. 3D TV is just a plane where you watch and it has sort of a 3D effect. This is literally 3D, where I can take my phone and I can look around it and I can get closer and farther away. And we're doing other cool stuff with this technology as well. We're doing a project in our R&D center in Korea right now where you take the phone and you look at a menu in Korean. I don't speak Korean, I can't read Korean, I can say a few words, but I can't read the menu. The phone actually overlays on the menu the English words. And if I tap on it, now it shows me a picture of the dish. If I look at the price, it shows me the price in dollars, so I know how much it costs. And it's just overlaid on top of the menu, so it just replaces that information. Now you imagine going around in the world, you can see everything around you, everything becomes clickable in the world around you. So this technology gives a user interface to the real world. And like I was talking about services, a digital photo frame here is a service. So the screen is a service. I might be in my house and I have a photo frame or a screen up on the wall and I have pictures on my phone that I want to do. So I just drag and drop from my phone over to the screen, and now when I take my phone away, the picture's on the screen. And this isn't PowerPoint. We actually have this running in the lab. So the screen tells my phone, this is how you talk to me. In fact, the one that we do, the real one, the screen actually starts glowing. And the glowing is attached to the screen. Even as you move around, it looks like that screen's glowing. When you move the picture to it, boom, it just gets translated. So you can imagine all sorts of opportunities with that. So we're really excited about that technology. It's another area of innovation. We actually have a software developers kit out, and we're doing a contest right now. So if you go to the Qualcomm website and any of you are software developers, you could build applications for it, or if you have ideas and you have friends who are software developers, you can participate in this contest. It's a really, really exciting thing. And so maybe just to close, I'll go back to what I said. This is not hype. The wireless technology, wireless communication, it's the largest platform that humanity has created. It creates a lot of opportunities, creates a lot of ability to innovate. It is, as I said, the way that we motivate our employees. We tell them, if you have ideas for innovation, then those ideas can get out and change people's lives all around the world. And that's a very motivating thing. And hopefully I've given you a sense of just how it is that the company that really thrives on ideas, and we had built a business model that allowed those ideas to get out in the world. How do we do it? And sort of how is it not a firm structure, but it's sort of a structure that allows innovation, because innovation is a very hard thing to do if you try and tell people, okay, now you innovate and you innovate. You don't innovate, you don't. You can't do that. You have to give people an idea and let them use their own experiences to build something within that. So with that, maybe we'll open it up to questions. But thanks, everybody.
I would like to express our collective thanks to you for your very exciting and interesting, informative speech. He actually earned not only bachelor's but also a master's and doctorate from Berkeley in electrical engineering.
Right.
Yeah. And he has been granted more than 35 patents for his inventions in the areas of wireless technology and wireless devices. Okay, let's have Q&A sessions. Do we have enough time, or sometimes about 10 minutes or so?
How are we doing? Did I go too long? Did I talk too long? Sorry.
Questions? 10 minutes. Okay, 10 minutes.
You guys needed to give me the high sign. Go faster.
Okay. Why don't you go ahead?
Thank you for your presentation. Your presentation makes me wish that we really had a company like Qualcomm in Korea. Because we do have innovative companies, but we don't have companies that have real core technology, that's that has so high impact and can actually change like so many people's lives. But I think in Korea, a lot of young people do have good ideas and new ideas. But I think the problem is, first of all, there's not that much entrepreneurship, maybe compared to the U.S. There may be a lot of structural reasons for that, but anyways. And secondly, more generally, I think young people are not willing to go into technology, like study science as much. Like this is a problem not only in Korea but also in the U.S. I guess. Like not enough IQ points are being allocated to like people want to in Korea. I guess it's more popular to go into become a dentist or something rather than being a scientist. And in the States, maybe more young people are looking into jobs in finance, rather than science and things like that. So maybe there is like a national kind of, we need some kind of action at the national level to kind of, try to harbor more innovation and try to create, companies like, Qualcomm. So I know you're going to be meeting our president, and like, would you have some kind of suggestions for how we would, try to, what Korea could do to create companies like Qualcomm?
Well, I think that the key thing that happened with us was that we understood that there was a reward to succeeding, and in fact, I think that happens well, for example, in Silicon Valley. That there's enough success that's been had, and people see that people are able to, improve their place in life and get access to all sorts of interesting things, and that helps. I think the other thing, though, like what happened at Qualcomm after we made it and many people got a lot of money, some of those people left because they wanted to do something else. But the people who stayed for this other reason, which was the ability to have impact. And I felt like in my my college days, I went to Berkeley, and Berkeley had not only the university there, but we were talking about this earlier, it also has this very strange kind of town around it. We call it the People's Republic of Berkeley. And it's all about sort of accepting diversity and other viewpoints. And I think that's really a critical aspect. And I think it's one of the reasons why the United States, kind of with that melting pot culture that we have, is more accepting of that. So I think there's a lot of reasons why innovation occurs. I look at it, it's a lot like trust. It's hard to build trust and easy to kill it. I think it's hard to build innovation and easy to kill it. But making sure that the rewards are there and that people see what the benefits of it are. And then I think also, just from an education standpoint, getting more engineering education, and more science, technology, and math education. These things are important, but we need to do it in a way that motivates people to want to get involved. So during the internet bubble, boy, a lot of people wanted to be software engineers. They saw what could happen. They looked at their computer and said, oh, well, I can get in the middle of that and do that. I think some of that's happening on mobile applications right now. But we do need to find ways to make it interesting so people get engaged and not turn people off at a young age to want to get into science, technology, engineering, and math. And you know, some of that happens at a national level. There are certainly policies that can happen. We're doing a lot of work on mobile and e-education initiatives, and that device that I showed you with the screen, we're going to do textbooks there, and people will be able to do multimedia, and hopefully you'll be able to make things that are more interesting. So physics, you can actually see the simulations yourself and play with them, you know, like Angry Birds or something, you know, these kinds of things. But you know, really show you the real physics. So I think it's a very broad spectrum. Funding needs to be there. The teachers need to be there. Maybe that's one other thing. One of the things that we've done in California is actually encourage people who have been in engineering jobs or science jobs when they retire to go back and teach and partner up with teachers to help the teacher sort of understand the material, and then that gets the kids sort of excited about it. So I think, like I said, it's a broad range of things that have to happen. And then finally, the piece about kind of being able to protect your ideas. So intellectual property is important. A lot of people push back about it because, as I said, they look at their costs and they say, oh, what am I paying this money for? And they don't like it. But in the end, when you pay that money, if you get value for it, it really is a nice cycle. And so we've actually funded some work here at the university to look at competition and intellectual property law and so forth. So those things need to get done right too.
One more question. Okay, back over there.
During your speech, you mentioned an analogy of an explorer of a compass and a map, right? I think the beauty of exploration actually lies in uncertainty, right? And that uncertainty may provide you with more opportunities for innovation, but it also entails greater risk. So I was wondering, as a chairman of a company who constantly brings new ideas to the market and realize something that may not even seem feasible at the status quo, how do you set a way of determining such a path for your company?
So I determine the vision, and as opposed to the path. But what we do, going to the risk-taking aspect, is I have a saying that it's okay to make mistakes as long as you don't make a career of it. Meaning that if you fail at things, you actually learn something. And so what I think my responsibility as a senior manager is to make sure that there's a pipeline of projects. So when somebody goes to work on a new project that's somewhat risky, they know that they're not risking their whole career on that project. And in fact, we have projects which have failed in the history of the company. Some failed, very large projects failed. And we work very hard to redeploy the people that worked on those projects to the next new project or to some project within the company. And that's a very continuous process in the company because we are actually on the smaller level killing projects all the time. This bubbling process is going on, not just for individuals, but it actually happens even in some of the formal structures where projects come and go relatively quickly so we can do a lot of experimentation. And it's absolutely the case in this day and age, you need to be very, very fast to adapt, to start things, modify them, and kill them if they don't work, or invest more if they are working. And we do it on all scales. We do it on the billion-dollar scales, and we do it on the tens or hundreds of $1,000 kind of project scales. And just for people to know that it's okay to take a risk and that they're not going to lose their job. In fact, we celebrate them for taking that risk. And of course, when they succeed, they get lots of glory. But if they fail, it's not a negative thing. And in fact, it's a positive thing. So that's another area that you need to give people the comfort that they can take those risks.